We are now on to 5.2, and this is Introduction to Functions. This is a brand new idea. And this idea can often cause a little bit of grief when you first learn it. So don't be upset if something doesn't quite click right off the dot. Now, what am I going to be able to do after this? I'm going to be able to understand if a function is a continuous graph or if it's the relation where all independent values have a single corresponding dependent value. So we're going to represent what a function is. We're also going to be able to describe and understand the difference between independent and dependent variables. So these are brand new words that you're going to be introduced to that is really crucial moving forward. You're going to understand how to state the domain and range, and this is using sets. And then you're going to know how to use function notation, okay? So there's lots going on in this video. In this video, if you need to watch twice, I would do it. I would look at other resources because learning all of these things is crucial moving forward. So let's look at the introduction to independent and dependent variables. So in a relation with two variables, one is the independent variable and the other is the dependent variable. So you always have you always have both present. Okay, your independent variable, this is the variable for which values are selected or have no control over. So this is something you either determine, or you don't have any control of. So think about something you don't have control of. Something you don't have control of is time or your age. It just happens, okay? In an experiment, sometimes you decide what happens. So in an experiment, you might decide, let's say, how much acid or a base that you include, and you determine all the measurements for that thing, okay? Your dependent variable is the variable that responds to the chosen independent variable. Okay, so this is the thing that responds. That's the big word that comes out of that. So think about what maybe responds to time or age. What responds to your age? Well, something that responds to your age would be the height, right? The height at which you are, how tall you are. You don't determine your age, but your age does determine your height, okay? You cannot control your age, and your height depends on your age. So this is definitely something that you're going to have to get used to. So independent variables, you either determine in an experiment or you just don't have control of. The dependent variable responds to whatever you're determining or the thing you don't have control of. We've already talked a little bit about domain and range, okay? But domain are all elements that are independent variables. So now you have another thing to kind of remember. You have to understand the domain is equals your independent variables. Where else does our domain pop up? Your domain also is the horizontal axis on a graph. Okay, so whenever you make a graph, now you not only have to remember that this is sometimes known as the x-axis, this is also known as your domain, and this is also known as and where you put your independent variables. Okay. Oftentimes these are known as x variables, and remember it's because it's on the x-axis. Not always though. Sometimes it could be t here, right? Sometimes your independent variable might be represented as t for time. Now, the range. So you got to remember what domain is, and now the range includes your dependent variables. Okay, so we know that the vertical axis here is known as the range. It's also known as the y-axis, but this is where you're going to put all of your dependent variables. Okay, so you have lots going on here, and usually this is known as the y variables, but not always. But it's known as the y variables because you always put your dependent variables on the range axis, which is usually known as the y-axis. Okay, so a few new terms to remember, definitely. Independent and dependent, domain and range. Okay, so independent variables is your domain variables. Dependent variables are your range variables. Okay, so let's look at a table. We've analyzed tables, and now we're just putting more mathematical, scientific terminologies to it. So here, we've sort of talked about how on the left-hand side and the right-hand side, this is known as your domain. Okay, so we can see here, our independent variables are always on the left-hand side, and then you have the domain set. Okay, because remember, independent and domain are essentially the same thing. Your independent variable is made up of your domain variables. Okay, and then you have your dependent variable on the right. Okay, and this makes up your range. So your range is made up of dependent variables. Okay, a table of values usually represents a sample of the ordered pairs in a relation, which is what we've talked about and you've seen in 5.1. So this, or you can't really see that. Number 1 here, 1 hours is related to $12 of pay. Recognize that here for hours, we have stated it's measured in H. And remember, time is usually an independent variable, if not always, okay? Because we don't have control of this. So you always put your independent variables on the left side and your dependent variables on the right side. The values of the independent variables are listed in the first column of table of values. These elements belong to the domain. So you want to remember this. It's stated over here that the values of dependent variables are listed in the second column of the table of values. These elements belong to the range. Okay, so you got to remember that. So here is our domain. Here's our range values. Okay, these are made up of independent variables. These are made up of dependent variables. So lots going on here. Okay, these points would be plotted on, or these are your horizontal axis. Horizontal axis points, and these would be their corresponding vertical axis points. Okay, so you could definitely graph this thing. So where 1 is, you'd put 12. Okay, so let's maybe make the graph of this thing before we move forward, just to get an idea of what this thing might look like. So here we have, I'm going to put time on the bottom, and that's measured in hours. And then this is gross pay. And that's in dollar signs. So remember, your independent variables are always on the horizontal line. Your dependent variables are always on the vertical line, or your y-axis. Okay. My independent variables, or my domain is going up just simply by ones. 1, 2, 3, 4, 5. And here it looks like I'm going up by 12. So, 12, 24, 36, 48, and 60. And now these ordered pairs, 1 and 12, I can represent this as a coordinate point, 1 and 12. Remember, this is always your domain value and then the corresponding range value. So when my range value is 1, in this case 1, when my domain value is 1, my range value is 12. So I'm going to plot a point there. When my domain value is 2, my range value is 24. So I'm going to find the point where those two meet. And then I'm going to erase. Okay. When my domain value is 3, my range value is 36. And that's found in these two coordinate points, or these two ordered pairs, 3 and 36. Okay, so hopefully you're seeing how all of these new terminologies relate to each other. So 4 and 48, and then 5 and 60. 4 and 48 is plotted here, 5 and 60 is plotted here. Something you can see here is these would be a continuous function, and it's pretty much a straight line. Okay, so this would be continuous. So that's just a little bit of review. Because we can work an hour and a half, and we would make roughly $18 because you worked an extra half hour, right? Okay, so lots of new terms. Now, let's move a little forward and let's do one more example. So this is all about what a function is, okay? So this is a new term. What is a function? So the basic idea of a function is a special type of relation where, and this is important, each independent variable have only one specific dependent variable, okay? We can state this another way. Another way to understand a function is each element in the domain has exactly one value in the range. So your domain values only show up once. Okay, so let's see how we use this. So use the information below to solve A, B, and C. So we have a table of values. This table shows the cost of student bus tickets, C dollars, for a different number of N. So here, recognize this side, I'll represent on the other side here. My number of tickets, this would be my independent variable. And why is that? Because we are choosing how many tickets we grab. We are choosing this. The independent variable is made up of the domain. So these values make up your domain, okay? Now, what's responding to how many tickets we buy? Well, that's the cost these things make. So this would be the dependent variable. And remember, it's kind of easy with this because on the left-hand side, you always pretty much represent your independent variable. On the right-hand side, you're always going to represent your dependent variable. What is the dependent variable made up of? Well, it's made up of the range. Okay. Now, we got to ask ourselves, is this thing a relation or a function? Or sorry, is this relation a function or not? Why? So remember what a function is. The function is where each independent variable only have one specific dependent variable. Now, oftentimes, this is actually easier to be shown using a circle graph. So we can see here, if we represent this using an arrow diagram, so this is N and this is C, so this is the number of tickets. And this is the cost. Okay, and we have 1, 2, 3, 4, 5, 6. Then $1.75, $3.50, 5.25, $7, and 8.75. Here we can see if we list these up, when we have one ticket, it costs $1.75. 2 tickets cost $3.50. 3 costs $5.25. Okay, 4 is $7. And then 5 is $8.75, and we actually didn't have number 6 represented in our domain. We can see that each independent variable only has a specific dependent variable. None of these go to the same variable there, okay? Or sorry, none of these are used twice. So no numbers in the domain are used twice. What does that mean? That means it's a function. So this thing is a function because of the fact that in your domain, they are only used once. As soon as a number in your domain is used twice, you're no longer a function. Okay, identify the dependent and independent variables. Well, we kind of already talked about that. My independent variable is n, number of tickets. Number of tickets. And remember, why is that? Because we are choosing it. Okay, and then our dependent would be our cost, because that's responding to amount of tickets. Now, we need to learn how to list the domain and range. Here we're going to use a set. So my domain here, I'm going to represent D, and this is where things get a little tricky, and I'm going to put a little squiggly arrow. Okay, and now I'm going to list each element that's found in my domain. So here it would be 1, 2, 3, 4, 5. And this would be my domain. I have listed each individual element found in my domain set. Okay, what about my range? Well, I'm going to put a squiggly because this is representing the elements in my set. This is my range set. And my range is made up of these numbers. So 1.75, 3.5, 5.25, 7, and 8.75. And there I've listed my domain and range, at least the elements found in there. So what is a function? A function is where your domain is never used twice. None of your elements in your domain is used twice. So let's go to example 2 and see how we can do it using ordered pairs. So remember, in ordered pairs, this is a domain value, and this is a range value. Okay, and that's what an ordered pair is made up of. So for each relation below, determine whether the relation is a function. Justify your answer. It also wants us to identify the domain and range of the relation. So here, let's figure out, is this a function? In order to figure out if it's a function, remember, do any of my domain values show up twice? Well, here I have 2, 4, 3, and 5. So domain is made up of 2, 4, 3, and 5. Remember, those first values mentioned in each ordered pair is a domain. Recognize we only ever have these showing up once. So this is a function. Because no repeated values in domain. Okay, so we've determined it's a function. Now it wants us to identify the domain and range. I've actually already listed the domain here, but I'll do it again. So the domain is 2, 4, 3, and 5, because it's those first numbers in each ordered pair. 2, 4, 3, and 5. What about my range? My range would be made up of 3, 5, 4, and 5. 3, 5, and 4. Now recognize I'm not going to state that 5 showed up twice. Now, you might be asking yourself, hey, 5 did show up twice. Doesn't that make it not a function? But these are the range values. A function is something where you have no repeating domain values. In a function, your range can repeat. So that's something to note here. In a function, range values can repeat. So this is kind of a note here. Okay, so your range values can absolutely repeat. Recognize I didn't have to state 5 twice because we already stated it. It's going to be here. So let's first determine if the relation is a function. So here, what's in my domain? I have -1, I have 4 and 4. I can actually stop immediately because I've just found a repeating value. So here I have 4 repeats in the domain. If you have a repeating value, this makes it not a function. In the domain, sorry. If you have a repeating value in the domain. So not a function, and this is because no domain values can repeat. Okay, so this is not a function. Let's list our domain of this thing. Well, remember, each number in all the ordered pairs are domains. So remember, it's always domain and then the range value. Okay, so here my domain is made up of -1, 4, and 2. I don't have to repeat 4 there. What's made up of my range? Well, my range are the second numbers in each ordered pair. So 3, 3, 4, and 1. So 3, 4, and 1. And there's my domain and range. So I would probably stop and go find a few questions that you can practice on, using the terms dependent and independent variables, using the terms domain and range, and determining if something is a function. Okay, please practice a few questions in your textbook. You'll be able to find questions in 5.2 to kind of check your understanding. And then I would suggest moving on to part 2.